Hello everyone. So here we shall solve some KCET previous year questions, chapter electrostatic potential and capacitance. In, in any of our solutions, if any of the steps are unable to understand, other kinds of doubts, if you have, write us in the section, or in any other chapter of physics. If you feel difficulty, then also please mention the name of that particular chapter section. Also, some more questions on every chapter uploaded in Sapience Education application. Please install our Sapience Education application has been provided in the description. Here we shall start with the first question chapter on electrostatic potential and capacitance. It is told that a parallel plate air capacitor has a capacitance C. There is a parallel plate capacitor, it is having capacitance. When it is half filled with a dielectric, it is half filled with a dielectric constant K of constant 5, then the percentage increase in the capacitance. So here initially, suppose the separation between the two plates is D. C is equal to epsilon naught A by D, where A is the area, A is the surface area of the plates. And initially there was air inside, air in between the plates. Here half of it is filled with dielectric constant K equal to. So this will be D by 2, this length will be D by 2. Here let's say that two capacitors, so it is equivalent to two capacitors which are connected in series, where this capacitance will be epsilon naught A by D by 2. This is C1 and this is C2, epsilon naught K A D by 2. Therefore, we can convert this capacitance into one single equivalent capacitor. Capacitance is suppose C dash. For 1 by C dash will be equal to 1 by C1 plus 1. Then 1 by C dash will be 2 epsilon naught A by D, epsilon naught by D, plus this will be 2K epsilon naught 1 by C dash epsilon naught by D 1 plus K. Sorry, 1 by C1. C1 is 2 epsilon, C2 is 2Ka by. We have to take its inverse. Inverse that 1 by C dash, that will be D by 2 epsilon naught A plus D by 2 epsilon naught. Therefore 1 by C dash, that will be D by 2 epsilon naught plus 1 by K. C dash will be K plus 1 K epsilon naught A. C dash will be K epsilon naught by K plus 1. So here K is equal to 5. So therefore this will be 2 into 5 epsilon naught K by K plus 1, that is 6. This is 5 by 3 epsilon naught A by D. Therefore, the percentage increase in the capacitance, the capacitance, C dash minus C by C percent. That will be dash is 5 by 3 epsilon naught by D minus this is epsilon by D, that divided by epsilon naught A by D. This will be 5 by 3 minus 1. So this will be by 3%. This will be 3.67%. Then question number 2, it is told the top of the atmosphere is about 400 kilovolt with respect to the surface of the earth. Here suppose the surface of the earth, the top of the atmosphere is about the top, this is about 100 kilovolt with respect to the surface of the earth, corresponding to an electric field that decreases with altitude. Near the surface of the earth, the field is about field at the surface that is about 100 volt per meter. Still, we not get an electric shock when we step up an house, because assume the house to be a steel case so that there is no field. We do not get electric shocks. There is a difference between body and the E and the ground form surface. There is there. Yes, so there. So know that when the atmosphere is dry, then there are no water droplets in it. Means there is no moisture in the atmosphere. Dry atmosphere, when there is no moisture, in the atmosphere, then it is not a conductor. It's not. So there is no flow of electric charges from the surface to the atmosphere. The top of the atmosphere surface. Dry atmosphere is not a conductor, so we not get an electric shock when we step out of get shock. So option D is the correct. Then it is told a gang capacitor is formed by interlocking plates as shown in the figure. The distance between the consecutive 0.885 centimeter. Overlapping area of the plates is 5 centimeter square. Capacity of the unit is. So this is like this. So then, so if we, so, so across these 2 points A and B, the equivalent capacitance we have to, there is told that the distance between the consecutive plates 5 centimeter, and the overlapping area of the plates is 5 centimeter. Area of the plates is 5 centimeter. Then the capacity of the unit is capacity of the, find the capacity, means you have to find the capacitance. Here we see that the capacitors are in parallel connection. That's why all are connected across same potential difference. They all are connected across the same voltage, so they are connected, they are in parallel connection. Parallel So this one is equivalent to, here one capacitor we are 1, 2, 3, then 3, 5, 6, 7, 8, 8 capacitors. So 8 capacitors like this connected in parallel. For the equivalent capacitor, C equivalent equal to C1 plus C2 plus C3 C8. So C equivalent is C1 plus C2 plus C3 till C8. So it means that C1 is, so all will have the same capacitance, that will be 8 into C, where C is the capacitance of a single capacitor. Capacitance of a single 8 into epsilon naught divided D. Epsilon naught is 8 by 10 power 12 into A. Okay. The area, overlapping area is 5 centimeter. We convert it into SI unit, that is in meter squares. 5 into 10 power minus 4 meter square. 5 into 4 by, so epsilon by D. D is 0.885 centimeter. D can be written as 0.885 10 power meter. You can say it is 85 8.85 10 power, this is minus 1 3 meter. This will be 8.85 10 power 3 meter. 8.85 8.85 will cancel, so the answer will be 5 bits of 50 into 10 power 3 minus 4 12. So this will be equal to 4 into 4. So that's why here we have 10 power 4 minus 4 12, 10 power 12. 4 equivalent capacitance, that is 8 into C equivalent 4 into 10 power 12 farad, or I can say it is 4 picofarad. Picofarad. And B is the then in question number 4 it is told two identical capacitors, each of capacitance 5 millifarad, are charged to potentials 2 kilovolt and 1 kilovolt. The negative ends are connected together. When the positive ends are also connected together, the loss of energy of the system will. So their capacitances are same, C2, C and C. They are charged to the potentials 2 kilovolt. Then here so initial energy of the system was initially energy. Each capacitances are same. One that is equal to 5 millifarad. So 5 into 10 is 3. The charge which is found on the first capacitor and charge on the second capacitor that can be found. Initially the charges are the charges on the capacitors Q1, C1, V1, that is equal to C2 and C2. Q1 that will be C1, which is 5 millifarad, 5 into 10 power minus 3, and V1, which is the potential across the capacitor 1, 2 into 10 power 3 volt, which is 10 coulomb, and Q2 CV. So C2 is also 5 into 10 power 3 V2. V2 is the potential of the second capacitor power 3, which is equal to 5 coulomb. Now finally their charges will come the same. Since their capacitances are same, therefore at C1 V1 their net charge will be C1 V plus C2 is equal to C1 C2. Or I can say that their total charge will remain conserved. So I can say that Q if final charges are suppose Q and Q. q 2q, that will be equal to q1 plus q2. It means that q will be equal to by 2, 7.5. So, when they are connected, then each of them will have 7 point charge. So now loss in energy, loss in the static potential energy, loss in the static potential energy is given as initial minus initial q1 square by q2, that minus, since why we know that the electrostatic potential energy is given as q square by 2c. Q is given as half cv square is square by 2c. These are the plus for plus the electrostatic potential energy stored in a capacitor. Static energy stored in capacitor. So this will be, so this minus this will be q dash square by c2 c1. This will be q1 square, 1 is 10 square by 2c capacitance is the same. This can be 1 by 2c I can take as common, square plus q2 square minus dash square for potential energy c by 2c 5 into 3. This will be square q1 square, q1 is 10 square plus 5 square, yes, which is 50, 7.5, 7 point square. And this will come by 10 power to 5. This will 5 by square Farad. This will be 100 into 125 minus 2 ones are 2, 1s are 2, 2 to the 4, so 10. This will be equal to 125, 112.5. 5, 3, 2, 100 into 12.5, which is equal to 125 joule. So Q1 this will be Q square. So this is 10 square by C. This will be or here we can do one thing. Half C1 V1 square plus half C2 V2 square minus half C1 plus C2 half C1 V square, where V is equal to know that C1 V plus C2 V, that is equal to C1 V1 plus C2 V2. C, so V1 V, that will be equal to C1 V1 plus C2 V2 minus C by C1 plus C2. If we put that, then we will get half C1 V1 square plus half C minus half of C1 V1 plus C2 V2 whole square divided by C1 plus C2. Now if we simplify it, then we will get as 1 plus C2 into 2. Here we will have C1 square V1 square plus C1 C2 V1 square plus C1 C2 V2 square minus square v2 plus c2 square v2 square minus will be this will be c1 square v1 square plus c2 minus c2 square v2 square minus 2c1 v1 c2 v2. So these two will get cancelled. c2 square v2 square will cancel, c1 square 1 square will cancel, but these will remains. So this will be c1 c2 to v1 square plus v2 square minus 2v1 v2 divided by 2c1 plus c2. This will be half into c1 c2 by c1 plus c2 1 minus v2 square. So it will be equal to half of c1 5. So both are same, so this will be c square by 2c v1 minus v2 square. These c and c will cancel, so by 4 1 minus v2. This will be 2 kilovolts, so 2000 minus 1000 be 1 by 4 in c is equal to 5 millifarad. So this is 5 into 10 power minus 3 into, it will be 1000 10 power 3 whole power 4. 10 power 3 whole power 2, 10 power 6. This will be equal to 5000 divided by 4 equal to 1250 joule. So none of the options are correct. And in question number 5, it is told, okay, so here we have to end the first part of this chapter. So hope you all have understood the every steps of these solutions of the first 4 questions. And any more doubts if you have, then please write us in the comments section. We shall clarify them in the subsequent videos. And please install our Sapience education application, where we shall upload some important homework questions on every chapter. Thank you.